This is a bank of relays, telephone relays, and the job they do for Theseus is similar to the job they do in your dial telephone system. Each time you use your telephone, the dial system has to remember the number that you dial, then guide your call through the maze of connections, the thousands of separate lines in a dial switching office. In a fraction of a second, it must find a trunk line free to carry your call. It also has to remember in itself what sequence of steps are necessary to make the connection for you. Here at the Bell Telephone Laboratories, we're concerned with improving your telephone system, making it work better to give you more efficient service. One of our continuing projects is on dial switching. Incidentally, the things we learn for the telephone system have other applications, too. We can use these telephone relays to build computing machines that can solve mathematical problems in a few minutes that would otherwise take many days to solve. We at Bell Labs also use this knowledge to build gun director equipment for the armed forces. The many factors which affect the aiming of guns and guided missiles are computed and applied by these machines in fractions of a second. Theseus is a simple demonstration of some of the things we can do with telephone relays. He's now had a chance to find his way through the maze, and there he's reaching the goal. Now let's see how well he remembers what he's learned. Theseus is capable of other types of intelligent behavior. He can add new information and adapt to changes. If the entire maze or part of it, for example, is changed, he will explore the changed area, replacing the old information that's no longer of value by the new information that he's just learned. Here, let me show you what I mean. Suppose I change the maze around a little bit. Let's say I take this partition and move it over here. And suppose I move this one over here. There are over a million different ways you can set up mazes on this board. Now we'll take the mouse and put him back in the same starting point, and let's see what he does. He's replacing the old obsolete information with what he's now learning about this new situation. Those copper whiskers of his tell him when he's up against a wall and has to try a different direction. Now he's through the change section, and his memory is correct for the rest of the way to the goal.
The remarkable thing about my association with von Neumann is perhaps that he, as a mathematician, could so quickly and easily penetrate into the problems of economics and sociology which I presented to him. That is very indicative of his basic philosophy, which was that mathematics should try to enter new areas, new fields, not only be inspired as it had been by the natural sciences. He expected that it would receive great stimulus from the other areas. And I'm sure that if he had lived, he would have made great contributions also, for example, to biology, in which field he was very much interested. But out of this study of sociology and economics on the one side and mathematics on the other came this book, which is the fruit of our joint association.
The theory of games was a landmark work in pointing the way toward the mathematization of human motivations. The theory deals with problems ranging from the two-person game, in which the goals of individuals are diametrically opposed, as in poker and war, to n-person games involving complex interaction of groups, and finally to insights into individual choice, as it is expressed in economics. In 1943, von Neumann was one of those who disappeared into the West to work on the Manhattan Project. Los Alamos, at that time, was a unique mixture of primitive living conditions, super secrecy, and brilliant scientific minds, all of which combine to create an atmosphere of intense excitement and stimulation. Von Neumann took part in most of the crucial stages of the bomb's development and was present at the detonation of the first A-bomb at the Trinity site. Nobel Prize winner Hans Bethe, leader of the Theoretical Physics Division in Los Alamos, 1943 to 1946.
In Los Alamos, in 1943, we had the problem of assembling uranium to make an atomic bomb. Dr. von Neumann was a consultant to the laboratory and visited us about 3 times a year for a week or 2 at a time. There were 2 methods being considered. One was to shoot the parts of the bomb together by a gun, and the other method was the so-called implosion, in which you surround the bomb material by high explosive and then explode this explosive so that the metal of the bomb would assemble in a sphere. In the beginning of the Los Alamos laboratory, only the first method seemed to be possible. It was von Neumann who told us and encouraged us to try the second, and who gave us a lot of information on similar work which had been done under his supervision at the Aberdeen Proving Ground in Maryland, in which shaped charges had been developed. He was very positive that an implosion could be developed, and he told us that this would have added advantages for the assembly which we had not realized. One of the advantages which we had realized was that the implosion would bring the material together much faster, and therefore would prevent detonation of the weapon before full assembly. Another advantage which he pointed out was that the implosion might squeeze the material and might thereby increase the efficiency of the weapon. Even after his encouragement, however, we still found it very difficult to assemble the material by implosion. There were experiments made under the leadership of Dr. Kistiakowsky of Harvard to study the explosive method without the uranium being around. And unfortunately, they gave all sorts of irregular shapes. Well, this did not trouble von Neumann at all. He suggested to us that we use something to focus the implosion, focus in a similar way as light is focused by a lens. And this device, in fact, has been called an explosive lens. Afterwards, he designed for us some configuration of explosive lenses which actually worked and which was finally used in the assembly that we used for the first bomb in Trinity and afterwards in Nagasaki.